Yeah, hi. So a lot happened since my last upload. So I uploaded it yesterday. If I'm uploading it today, then but the video was actually recorded like a long time ago. So yeah, for you, ideally, if you're watching it live, which I hope nobody does. Uh, so yeah, basically, this is a new board. In case you can't tell, this does not erase as well. There's some tilt. I can't deal with any of that. And yeah, it's just I'll try to cover three topics today itself. So let's hope that happens. And yeah, let's get started, I guess. So functions, right? Yeah. Okay. So first thing to note is what's the rule of assignment, right? I so from whatever I studied, right? I can't do that. I can't do this anymore. A function is well defined, right? You may have heard that term, and essentially, a function is not a function if you're getting two values for the same input, right? That's how you may have learned it. So that's precisely what the rule of assignment is, right? If C comma D is C comma D comma C prime comma D, um, sorry, that's there. Sorry, yeah, yeah, are both in F or R or whatever you want. That a function is ultimately first subset of Cartesian product, right? Which will be defined even more rigorously later. But we have a pair of we have an ordered pair, so from that we can define it. So yeah, this is a rule of assignment, and another way of saying that is wait, yeah, the function is well defined. That's another way of saying it. So that's one thing, and this will be used in proofs. What's the other thing? The other thing is what a function is, right? So we have the rule of assignment, which is just a way of saying a function is well defined. And the other thing is the function needs so there's a domain of the rule of assignment, and the function's domain is that the function is defined on that domain on the domain of the rule of assignment. There, so let's say I'm using an example of a function before defining it, but that's fine. So we take 1/1 minus x, right? So you may have studied that one is not in the domain of this function, right? Yeah, you can see me, right? Yeah, you can see me. Okay. Yeah. One is not in the domain of this function, but you wrote it like this. So you can't do it from now onwards because the definition of the function does not, it only is, this set must be the domain of the rule of assignment. And since the rule of assignment doesn't make sense at x is equal to 1, we can't include it in the set. So there's no need to include the domain of the function in the definition. And yeah, function is just the domain. Essentially, it's a rule of assignment, and which means it's well defined. That's another way of looking at it. And it sends, yeah, it has a range which contains the image set, and the image set you can see the definition, right? Okay, that's it. And there are examples. You can check it out. Composition, right? So you see how the book defines various functions through rule of assignments, and you can just use the rules. And we have our first rule of assignment for composition functions, which is there exists B belongs to B, such that you know the thing, yeah, right? G of B is equal to C, and F of A is equal to B, right? And that's how you get a composition function. So yeah, the range must match of the domain of G. That's one thing, and keep in mind that F need not be surjective though. So it could go from a partial. So let's say this is the whole range, and F goes only here, and then G could only be defined that way. So we can still have a composition. It just requires an existential witness. That's what the quantifier signifies. All right. 1 to 1, and I check this. So 1 to 1 is just f of a prime is equal to f of a implies a prime is equal to a, and the contrapositive is also useful. So a prime not equal to a implies f of a prime not equal to f of a. So the contrapositive is sometimes used in proofs. And surjective just means for all C belongs to, so f is a function from A to C here. For all C belongs to C, there exists A belongs to A such that f of A is equal to C. That's just, so yeah, so it's just quantifiers, and here it's an implication. Think of it that way. All right. Inverse function will be tackled in the exercises. Uh, yeah, the image set and the inverse image set, right? So there's that now. There is it. Yeah. This should be covered quickly. Like I solved the exercises before recording this. So yeah, I've spent most of the time thinking. So that part at least shouldn't be a problem. And from now on, I'll solve the exercises before recording. So I don't want to waste too much time. Right. Not sure if I'm wasting time though. Yeah, image set. So f of x, uh, f is a function from x to y. Right. F of x is equal to b. There exists x belongs to x such that f of x is equal to b. Right? That's it, right? Yeah. So I'm just changing the x for at least one part. So any existential witness, keep in mind, as discussed in the previous exercise, that if something belongs in the set, then we can invoke its formula and vice versa. And that's precisely what we'll be exploiting in the next exercise. So coming exercise. So because of that, I'm writing the quantifier. So we can invoke and prove that it's we can invoke it if it happens to be a member, and we can show that it's a member by proving that the formula is satisfied. And same thing for the inverse image. It's a lot simpler. B f of b is an x. Oh, sorry, y. Yeah, right. So this another way of writing it is that f b is in f inverse y if and only if f of b is in y. That's precisely what I'm trying to illustrate here, right? Yeah, so there's the subset and in inverse subset property. Will be proving that in the exercises too, so I'm not too bothered about it. But the intuition you want to keep in your mind is that inverse images typically expand the set because functions are well defined. So you can have multiple inputs leading to the same output, but you can't have one output coming from you can't have one input leading to multiple outputs. So because of that, the inverse images typically expand, and the image sets are typically contracting, right? And because of that, those properties hold. They're in the book. I'll prove them. Anything else? Yep, there's the example, and yep, let's go straight to the exercises. There's not much to study here. It's the exercises that have a lot of insight. So let's go there.